welcome to Edison Open House Transport Futures 2021. Cell Impact is a Swedish company whose technology enables the mass manufacture of the flow plates needed for hydrogen fuel cells. With me is their CEO, Per Taker. Per, hello.
Hello, Vivian, and thank you for having me. I'm looking forward to this conversation we will have.
First of all, just explain what are flow plates and why are they so important in the manufacture of a hydrogen fuel cell?
Well, a flow plate can be used in a fuel cell or a PEM fuel cell, and for that matter as well, a PEM electrolyzer. You can think of a fuel cell as a battery, and in the battery you have a stack, and that's where the flow plates fit in. And the flow plates does a number of jobs, but you can really think of it as a cell that goes into the battery.
Now, why is your technology so important in mass manufacturing these flow plates?
Well, the industry is challenged with one thing, several things, but one that is really a significant challenge, and that is to scale up. And we have a technology that is good to use when you scale up because it comes with a low capex, low opex. And the competing technology that we usually meet is equipment that is very large. So when you buy an equipment like that, then you actually end up pursuing a factory accommodation project. Our equipment is very small and it's very easy to fit it into, let's say, an existing industrial facility. So low capex, low opex, and then also when we are scaling up, it's ideal for that challenge that fuel cell manufacturers are presented with.
What you're able to do is essentially mold, and I may not be using the right technical word there, but mold very thin metal. Now, why is that important?
Actually, it's more like forming, shaping a thin material. It's 0.1 millimeter thin. And therefore, when you produce this one, it takes on the characteristics of a piece of paper, actually. But fuel cells or the flow plates then that goes into the fuel cell tend to have very tough radiuses. And to form these, you need to have a certain process. And that process typically entail high speed and a very distinct forming event. And that is what our technology delivers.
So essentially, you're trying to smash something as thin as a piece of paper really hard and expect it not to break. So that getting over that problem.
You can put it that way. Yes, you can put it that way. But you also need to do it with a great or a high speed, both in terms of the forming event, but also you need to have a high or a low cycle time. So you need to produce these flow plates. When we form them, we can form a flow plate in 1 second quite easily. But if you look at the total production system, you need to have a fairly good takt time, as they call it, and we are talking about maybe seconds in that system as well. So it's all about productivity and the possibility to scale up here. And so we have the characteristics in our technology: high speed in the forming event, and then low cycle times, very small, nifty equipment, low capex, low opex, and so forth. And you also have some life cycle costs in an equipment like this. And then we are talking about the tooling that goes into this. And it's important that you have a long life cycle on the tools, because the tools themselves are very expensive, and that in its own right can become a very heavy burden for fuel cell manufacturers. And we then fortunately have long life cycle in our tooling, and they come at a comparatively lower price as well.
And all of this is enabling the uptake, the mass uptake of hydrogen fuel cells for a hydrogen fueled transport future.
I would say so. We have some very distinct benefits in all these headlines that I have given you.
And are you benefiting at the moment from the investment that's starting to flow into these technologies?
I would say so. We are a small. I mean, when we started with our current strategy in 2018, when we shifted away from being a machinery maker to a flow plate manufacturer, we have added on some 60 people, operators primarily, but also engineers, and we started out with 10 people in 2018 now. So I think that this is an indication in its own right how much there is to do. We have a very uh, strict focus on a number of select leading fuel cell manufacturers. And we grow with them both in terms of, let's say, the business, but also in terms of the learning journey. And therefore, I would say that we've had both the good timing and with good hard work been able to actually become something in this industry in the span of 3 years. I would also say that we tend to live in two different time periods. I think before the EU Green Deal, we could certainly see some good momentum in the hydrogen industry with fuel cells and electrolyzers. But I think after the EU Green Deal, we talk about a new time era. And we've seen a very good uptick in the number of inquiries from both fuel cell manufacturers and electrolyzer manufacturers. So I think that we are an example of that it does happen already, and we are also an example of that there will be a lot more to do now. Once the industry, on the back of the EU Green Deal and all the other government initiatives now that comes to have a green restart of the economies.
Given all of that investment that's coming from the EU Green Deal, how do you see the fuel cell sector in general developing in response to all these initiatives to decarbonise transport?
Well, as you know better than I do, probably, if we start with a bigger picture and we are looking at the Paris agreement, we need to have hydrogen there to deliver on those targets there. So I would say that if you now look at the EU Green Deal, that what is important there is that this is not a long-range plan that we are going to do something in 2040, 2050, but this is really a here and right now plan with a significant amount of funds going into really kickstart, for example, hard to abate sectors, steel manufacturing being supplied with green hydrogen and so forth. Yeah. So I would say that this is probably the most important event that we have ever seen in this context, with hydrogen as an energy carrier, and then in the extension of that, fuel cells, PEM fuel cells, that can then fit into a number of sectors, not only transportation, but energy storage, aviation and so forth. So I think that this is something that is really going to have a very big impact. Fuel cells are already here, right now. They are used in logistical equipment like forklifts and the like, buses and smaller trucks and so forth. So this is not something that is going to come in the future. This is already here. It is true that the automotive sector is still preparing for the big introduction, and that's going to be a few years down the road with the automotive OEMs, and that is cars and trucks then. But this is here, and it's going to accelerate and expand significantly going forward.
So what's your vision of the future, Per? Because at the moment we think of hydrogen fuel cells, as you said, in larger vehicles rather than in automotive. But how do you see the future of transport with hydrogen?
I think we have to divide it into two discussions. One is the technical discussion, and here we don't know that there is a discussion about what should it be. Should it be battery electric or should it be fuel cell electric? I think that the battery is here to stay, but I think that the battery is probably going to be more applied and used like it is today within the consumer electronics area and other areas. But I think that transport and all the other areas we typically talk about when it comes to a fuel cell or a battery, that's going to be a fuel cell, because we need to recognize that there is a significant difference between hydrogen and battery minerals. When we source battery minerals, we are going to make ourselves if you wish, as Western nations, on countries that maybe don't share our views. And we don't want to be dependent again, like in the oil and gas era, on countries where we have to negotiate supply and depend on a whim, so to speak. And there is a certain scarcity of minerals. The visibility of the availability, if you wish, is only some 20 to 40 years here. So this is a serious matter in its own right, and it's probably not a good idea that we spend hundreds and thousands of dollars on building a future where there are so many risks. In addition to this, you can mention social issues and so forth here. So I think that whereas battery chemical aspects and effectiveness will change and improve, I think that the fuel cell offers the opportunity for energy independence. You can have your local electrolyzer in the local context as part of an energy system, and you can be the benefits that you derive from that is that you have local storage, local supply, and you can be part of a let's say, a regional European context, and you can free yourself from all the difficult aspects that you have when you are going to make yourself dependent on either somebody who supplies a carbon or a mineral. So in my world, there's no doubt about it that give it some time and let the issues with the battery come, so to speak, and then you will see that it's going to be a lot more hydrogen and fuel cells on the agenda.
It's clearly a very exciting future for Cell Impact. What are the big things that perhaps investors should look out for in the coming year?
I think the value chain now in the hydrogen sector is shaping up, and there are a lot of good different opportunities to invest and support this sector. And I think there is a growth coming here that is attractive to investors. In our case then, Cell Impact, I would say that we are a vector in terms of scaling up, and we offer something that is good for the customer in terms of the product, form, fit and function, good quality, good cost and so forth. And this is a critical component that one should try to look for in this sector. What are the critical components? We represent one of those critical components. And then it is the scaling up, and it's the scaling up of in support of those who have already done a lot of R&D and who are ready to make a move and introduce new products to the market. But Cell Impact, due to its low OPEX and CAPEX, can also assist companies that are at an earlier stage in product development and even R&D, because we have a low CAPEX, low OPEX. For example, to buy a tool from us is a lot less dearer than the alternative technology, we believe. So I think we fit in both the high volume scale up and also in the support the R&D and the product development space. But we are very well positioned to now participate in the scaling up. And I think another good thing with us is that now then when we scale up, there is an element of that things are a little bit unplanned. There is now a lot of enthusiasm, and we want to make moves as an industry, and it's going to be quite fast, I think, in many contexts. Companies will change their plans. We then have a technology that is also coming with a short lead time in terms of the scale-up aspect. Our equipment can be made available within, let's say, 6 to 12 months. And usually in these kind of contexts, it takes maybe 18 to 24 months. So we as a company are very well positioned, and we are ready to move on the opportunities that we have, expand those, and then also to join the flow with the other opportunities coming.
It's a really exciting area, and thank you for telling us about it. Per, it's been a delight.
Thank you, Vivian. Thank you. It's been a pleasure and a good opportunity for us to share the story about Cell Impact.